Welcome to this example, which says at the top, note, you will need to open StatCrunch to solve this problem. Open MyLab and find StatCrunch. So what's the question? It says, find the relationship between the amount of time statistics students study per week and their final exam scores. The results of the survey are shown below. So here's a bunch of students, and they surveyed them. And so the first student here, he or she studied on average 1 hour per week of homework in stats and got a 59. It's like he or she failed the final. The second stats student studied on average 9 hours a week of homework, got a 73 in the final. The third stats student studied on average 12 hours a week, got 100% on the final, et cetera, et cetera. Looks like there's 1, 2, 3, 4, 5, 6, 7 students were surveyed out of a statistics class. The last one got studied 9 hours per week on average for stats and got a 92 in the final. So the question is there a relationship, a connection between time and score on the final? We call that a correlation. We're looking to see if there's a connection, a correlation. Specifically, we're going to investigate if we can find a linear regression, a linear connection between time spent studying and scores on the final exam. So to do that, we're going to need to do what it says right up here. Open MyLab, find StatCrunch, and put this data ourselves into StatCrunch. Now, you may be able to copy and paste the data in there on your computer or iPad or tablet or whatever you have. But I'm going to have to type them all in one at a time. However it is, put that data into StatLab. So let me go there. So here's my lab. See StatCrunch over in the middle left. You can go this way, or you can go to an old homework problem. You can just open up an old homework problem and click Open StatCrunch. That'll work fine. I'm going to go straight from the outside here. Click StatCrunch. When you do, this will open up. And then you click, or actually, let me try that again. When you click StatCrunch, this will open up. And now, see right in the middle, it says StatCrunch website. The second arrow in the middle. I'm going to click on that, StatCrunch website. Then this opens up, and then click the yellow box up there, Open StatCrunch. The top, the yellow box, Open StatCrunch. And when you do, I've already done it, so I'm going to jump right to it. Here it is. And then I actually typed in the data. Now, again, you might be able to copy and paste the whole table right in there. It worked on my laptop. I did that, but right now I'm on my iPad, so it didn't work. I had to type them in. So there it is. The data's in there. I just typed it in. You can copy and paste it. So here we go. First, we need a graph. I clicked on graph, so I just clicked on graph at the top, and now I'm going to go down to scatter plot. And then it says, okay, what's X, what's Y? Well, X is my first variable, variable one, and Y is my second variable. So there we go. And that's really all we need. And just click something. Click. Oh, there it is over on the right side. Compute. Boom, there it is. There's the dot plot that we're looking at. So there's the dots. Huh. Okay, no, actually that's not totally necessary. I just wanted to see it. All you have to do is I'm going to click on stat. And so now I just clicked on stat menu, and I'm going to come down to regression. See regression down there in the middle? So stat, regression, and I'm going to click on simple linear. Stat, regression, simple linear. Let me go write that down for you. Stat, regression, simple linear. Stat, regression, simple linear. Stat, regression, simple linear. So that first thing I did is, and this will be X, this will be Y. It's called var1, and variable 2. I looked at the picture, the dot plot, but we don't really have to have that right now. So I'll just get right into the nitty-gritty details. All right, so here we go. Back to it. So X is var1, Y is var2. I'm going to do a hypothesis test. Yeah, let me go show you those details real quick. You come down here. This is going to be R equals 0 and R not equals 0. Those are both, you choose R for both those. So R equals 0, R not equals. R is the same rho or R. They're the same thing. Rho, that P thing that looks like a P there, it's called rho. It's a Greek R. So rho, R, whatever. Oh, we're choosing R here. So it looks like I get those off a little bit. So we're choosing R, which is the same as rho. Okay, so let's go back to it. So I'm going to put in right here. It's already got it right. Equals 0, right in the middle. The hypothesis test equals 0, not equal 0. Come on down. And I'm going to go on over. So it's ready to go. So I just put in the x variables var1, that y variables var2. The hypothesis test is already on equal 0, not equal 0. Um, and everything else is good. Let's click compute in the upper right corner. There it is. So there's my results from the calculator. Let me grab those and bring those over for us. And I'll paste them in here for us. There they are. So the computer just gave us. So the first thing it wants is this R value, 0.8548, da 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 da. So there's that answer right there. It's already on the screen for us. Okay, next thing is it wants the p-value. There it is, 0.0142. Where do we see that? Right here, p-value, 0.0142. So that's correct. Come on down. Okay, now what does that mean? So now we're going to get to some of the real life meanings of this stuff. Use a level of significance alpha 0.05 to state the conclusion of the hypothesis test in the context of the study. Okay, so what does it mean? So you remember how we do this, right? We always do p-value and then significance level. It's also called alpha significance level. Okay, what is our p-value? P-value is right here, 0.0142. What's our alpha level? Right here, 0.05. So which one of these is bigger or smaller? This one's less, right? Oh, 1 is less than 5. So what does that mean? Well, you know the saying, right? If the P is low, then HO must go, meaning go away. If the P is low, the null must go. If the P is low, the null must go away. Is our p-value low? Yeah, it's less. It's less. So that certainly means it's low. It's less. So the null must go away, which means what? Which means reject the null and reject the null. And that will always mean, let me bring, if you look at the boxes I've written on the board before, reject the null, strong evidence. Strong evidence. So, okay, so that means we're rejecting the null and we're also keeping H1. If we're, because remember, there's two options here. Let me make that one more clear. So reject it. So keep H1, strong evidence, right? Because HO and H1 are the two options. They're like two attorneys in a court of law arguing. HO is saying R is equal to 0, and H1 is saying, no, it's not. R is not equal to 0. So which one has the evidence? We're rejecting HO and keeping H1. So we're going to say, oh, okay. So we're keeping H1. So we go back here and we believe the evidence points to H1 and we're rejecting HO. So, and we're saying that's strong evidence. So that is, that R does not equal 0. Now, in particular, the information we want to use, what this means is if R, let me come back here to be clear here. If R equals 0, if R equals 0, that means not linear. If R is not 0, that means linear. So we're going with H1, right? We rejected over here. We rejected HO. Rejected HO, keeping H1, strong evidence. That takes us back. We believe R is not equal to 0, which means it's linear. Our results, remember, R is a measure of how much the dots make a straight line, how tight they are to make a straight line. And if R is 0, then they don't make a line at all. That's why we say not linear. If R is not equal to 0, specifically if it's far from 0, close to 1 or -1, then we say, hey, the dots are making a line pretty good. They're making a pretty tight line. That's us. We're rejecting HO, keeping H1 based on the evidence. When we put this table into StatCrunch, it told us, hey, there's strong evidence. You should keep H1. So we're keeping H1, which says R is not close to 0, which means that R is close to 1 or -1. The dots make a line pretty tight. Strong evidence for a linear equation. Okay, so then which of these 4 is it? Well, you can see the answer right here. I hit the key already. There's significant evidence to conclude that there is a correlation. Thus, the regression line is useful. Significant evidence. There is a correlation. The regression line is useful. So strong evidence, significance. We cross out, insignificant, no way. And then this one, the regression line is not valid. No, we cross that out. That's why that's not right. So that leaves the one correct answer, which says strong evidence. There is a correlation. The regression line is useful, meaning they really do make a line, pretty close to a line. There's strong evidence to make a line, so we can use the regression line. Now let's get to that. Next part D. It wants R squared. Let's go over to StatCrunch. The answer is already there for us, 0.73. Let's see where that was on StatCrunch. Right up here. Oops, I am in the right place. No, I'm not. I'm getting lost in my work. It's up here. There it is. So R squared right there. R squared. So that is R squared. 0.73. We get that. Now, what does R squared mean? Well, here's what it means. It means this one right here. It means that 0.73 means 73% of the variation in the final exam scores is connected with the amount of time they spend studying. Do you see, R squared is a measure of how much one thing affects the other. We know life is complex and many things affect many things. So for example, when it comes to how students do on the final exam, and I know you might have a different one, you might have seeds or some of the other versions, but in this one, we're saying, okay, how long they study affects their final exam score. Yeah, it does, but that's not the only thing, right? Also, whether they took a lot of math classes in high school or whether they're, just generally got a strong math background or they're quick at math or they have a good calculator. Other things can affect their score other than just how much time they study. So the question is, how much connection is there between time studying and scores? Well, 73%. That's what R squared tells you. It's 73% of how good they do in the final is connected with how much time they study. The rest of how good they do in the final has to do with, maybe if they've had stats before in high school, or they took a lot of other math classes, or, they have a really clear explanation, a good tutor, whatever. 73% of how good they do is connected to how much homework they do every week. And the rest of how good they do is connected to other things. That's what R squared is, a measure of how much one thing affects the other. Because life is complex and many things affect things. All right, now we come down. We're going to get the equation of the regression line. Well, there's the answer already. Let's go see where that is in the output. So that is right here. Boom and boom. So the intercept and the slope. So it's going to be y equals the intercept, 61.877574 plus, and then the slope, 2.92334 x. So this was the slope. This is the y-intercept. Now they had us round it, right? 6.188? Yeah, and 2.92x, 2.92x. So 61.88 plus 2.92x. There it is, rounded. So you get those right there. All right, that's the equation. Now, it says use the model, which means use that equation. That equation is a model of reality. Model of reality. Notice if we looked at StatCrunch, there would be a bunch of dots. If we graph this on StatCrunch, we would see a bunch of dots, and those dots would have a line going through the center. In fact, maybe we should do that. Maybe I'm wasting your time, but I think it might be useful. I don't know. See if I can do that easily. No, I probably can't. Here, I'm gonna go close. Okay, back to you again. Okay, graph. I hit graph, scatter plot. I'm gonna make the X var1, the Y var2. I'm gonna hit compute. Boom. There's the dots. See those dots? That's a scatter plot. That's a picture of that data with the x-axis being the let me just bring this over. We can write on it. That's a picture of the data there. You don't, this isn't required. I just wanted you to see it. So that's the scatter plot that StatCrunch gave us. And so see those dots right here, 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 here. Those are the students. This is hours they spent studying. This is the score they got on the final, right? Because the x-axis is hours, y, right? Var1 is x, var2 is y. And so there it is. There's like, here's that person that got 100%. See, way up here at 100%. That person studied like 12 hours a week or something, right? And then here's all the other dots. So those are the dots, the people, how many hours they studied, and how they did on the final exam. Here's a person that only studied 1 hour a week and failed the final exam. See how the dots go up to the right? In fact, you could estimate that there's a line going through the center here. About like that, huh? I'm just guessing. So there's that line looks like it kind of goes through the middle. And then the equation of that line would be y equals what we just figured out. What is it? 61.88 plus 61.88 plus 2.92. 61.88 plus 2.92x. That would be the equation of that line. That line's called the regression line, the best fit line. Call it the best fit regression line. It's the line that fits the dots best through the middle of the dots. And this is its equation. Remember equations of lines from your earlier classes in high school when you have the equation of a line? This is the equation of the line that fits, but the calculator, StatCrunch just calculated the equation of this line that fits best through the middle of the dots. Okay, so let's get back to the answering the questions. That's what that is. Now it says use that model, use that line equation right here as it's predicting, it's modeling and predicting reality to predict the final exam score for a student who spends 8 hours per week studying. So if somebody spends 8 hours per week studying, remember in this table, come back to the table here, this is X and this is Y. So X is time, Y is score. So if they say, okay, they spend 8 hours per week studying, that's X equals 8. So we take that and we plug it in right there for X. And what do we get? We get 61.88 plus 2.92 times 8. So then hit the buttons on your calculator. I'm going to hit the buttons on my calculator. 61.88. 61.88. Oops, too many eights. 7.88 plus 2.92 times 8 equals 85.24. So in other words, that's what we pick. Remember, this is y equals. So y equals. So we plugged in x is 8, x is hours of studying, and y came out to be that's the score, that's the predicted score on the final. In other words, if a student spends 8 hours per week on average studying for the class, we predict that this equation predicts that they'll get an 85.24. That's how we got this answer here, 85. They want you to round to this whole number. So we predict they're going to get an 85 on the final exam if they study 8 hours per week. How to make that prediction? Well, we started with that original data, X's and Y's, put them into StatCrunch. StatCrunch cranks out these dots, showing the scatter plot, and it calculates this line right through the middle of the dots, the best fit regression line. And this line represents how the dots flow and can predict how people are going to do in the final based on how many hours they study. So that was what we just did on that one. So the next question, interpret the slope. Okay, so which one's the slope? Remember, the slope is the number next to x. So if we say, okay, y equals 61.88 plus 2.92x, then this one is the slope. So you take that 2.92, it's positive, put it over 1, and that's y over x. That's what you always do with slope. So with slope, you always do y over x. That's just what slope means. It means change in y over changes. Now, why you might wonder, why'd you put it over 1? Well, I wanted to make it look like a fraction. Didn't change it, right? If you put something over 1, if you divide it by 1, it doesn't change it. If you divide by 2, that'll make it half as big as it was. But if you divide by 1, that doesn't change it. I just wanted to make it look like a fraction. Why? Because then I can go with the definition of slope. Remember from high school, slope is rise over run. It's y over x. It's how fast the line goes up as it goes over. It's the steepness of that line. Okay, so what? Well, what is y in this problem? Remember, back to the beginning, y is score, x is time. Y is score, x is time. So this is score, and this is time in hours. So in other words, this slope means for every one more hour of studying they do per week, their score in the final is going to go up by 2.92 on the final. So, if they go from studying 7 hours a week to 8 hours a week on average, their score on the final exam will go up 2.92. It's how fast their final exam score goes up based on more time spent studying. And so, right down here, that's why we have this answer right here. For every additional hour per week studying, the they tend to score on average 2.92 higher on the final. Finally, last question. Oh, by the way, I will take notice now. If on part G, let me go back to part G. If you answered on part C, the use of the regression line is not valid, you should have put D and E here on yours. Now, I didn't, but so if you go back to part C here, if you picked the one that says the regression line is not valid, and why would you do that? Because your p-value is like 0.06 or something bigger than 0.05. In that case, the p would not be low. The HO must not go away. You would not reject HO. You would keep HO, and HO says not linear. So in that case, you would say, okay, it's the dots really don't make a line, and the line is not valid. The dots don't make a line, and even though we have an equation of a line that sort of goes through the middle, the dots don't really make a line, and the line's not valid. And then you would come down here, and it says if you answered that on G down here, it says if you answered on part C, it's not valid. Then you would just put D and E here. Why? Because you can't be using the model. You can't be using the equation if it's not valid. So that's the trick here. Do you understand that whenever our p-value, whenever our p is greater than 0.05, so I'll just say if p is greater than 0.05, then we put D and E here on part G, H, and I. But D and E on G, on H and I, we would say because the p-value is greater, because p-value is greater, dot, 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 not valid. That's what you would choose for H and I. That covers H and I. So basically, if your p-value is greater than 0.05, then you cannot be using that equation that the computer gave you. You think, why the computer gave it to you? Well, computers aren't smart. They're artificially intelligent, but not truly intelligent. They just do what they told really, really quickly. So it just gave us these numbers really quickly, but it doesn't know we shouldn't use that equation. Why shouldn't we use that equation? Because there's not strong evidence that the dots really do form a tight line. They're just dots everywhere. Well, then why did they come up with this equation? Well, this is the line that fits best, but it doesn't fit well at all. The dots are just crazy. If your p-value is greater than 0.05, that just means your dots are crazy. They don't make a line very good at all. So you should not be using that equation. You'll still find the equation in part F, but then G, H, and I, you're just going to say D and E on G, as it tells you right here, which means does not exist. And on H and I, you're going to say, because the p-value is greater, it's not valid for me to talk about the slope or the y-intercept. I shouldn't be doing that. So that's what you would have to do. Now, on part I, final one, but in my case, my p-value was less, right? My p-value was 0.01. So it is valid, and I'm answering all these questions. So finally, part I. Interpret the y-intercept. So what's the y-intercept? Well, that's the other part. That's this right here. That's the y-intercept. Is that 0.6188? What does that mean? Well, if you have the equation, let me write it right here. Y equals 61.88 plus 2.92x. If you remember what x is, it's hours of studying per week on average. Y is final score, right? From the beginning, y has been final score, x been. So what that means is, right here from the beginning, x is time studying, y is score in the final. So that means if you take this equation, if you plugged in a 0 for x, meaning you studied 0 hours per week, what is y going to equal? 61.88 plus 2.92 times 0, because that x is right next to it. So that's just gone. So y would just equal 61.88, meaning that's the score you get on the final if your hours of studying are 0. You study 0 hours per week, this predicts that you'll get a 61.88 or about a 62 on the final. The best prediction for a student who doesn't study at all, right? 0 hours per week, X is 0, they'll get a 62 on the final. That's what that's saying. That's what the y-intercept is. Because if you plug in X 0, then that part just drops off and y just equals that part in the front, the y-intercept. So the y-intercept is the score the student would get if they studied 0 hours per week. They would get a 62 on the final is predicted. That's what that means. All right. Now you might get what? Now, what if that had been negative? What if that was like negative? Sometimes it'll be negative 61.88. So that would mean if you study 0 hours per week on the final, we're predicting you'll get a negative 62 in the final. Well, you can't get a negative on the final. That's impossible. In that case, you get something crazy like that, then you would choose the y-intercept has no practical meaning. If you have something negative that can't be negative, you would just say, yeah, it's not practical, because sometimes it's not. So that's how we do all of that.